Hi folks, so in these questions here, what we're going to do is a few questions here based on the topic of transformation geometry, and specifically these questions here are all in relation to axial symmetry. Now they come from a workbook from the World of Graphics workbook, okay? So I'm going to zoom in on this little guy here. I'm going to start with this one here on the left hand side, this little guy here. So what we have is, we have to do an axial symmetry of the objects in the lines, and you can clearly see they've given us the axis line already, and they've also given us the position from A to A1. Now what I always get my students to do is I try and get them to index. So if this point here is A, well then look, we'll call this point here B, C and D, and we'll work on the top portion then in a second, but just starting with those points there. So we can clearly see that we've been given the axis, and we can see then that the line has been projected perpendicular to the axis to find the point. So it's the same rules then that will apply to all the other points. So I'm going to do a little bit of sliding set squares here. So I'm going to take my set square and I'm going to position it on A, and all I'm going to do here, just zoom out a little bit, apologies, all I'm going to do here now is to find all the other points. I'm just going to do a little bit of sliding set squares parallel to the line A to A1. So parallel to A to A1, slide it along until I get to B, bring B down, same with D, and I'm going to have to adjust this now slightly. I'm going to have to move my set square over here, just with the visualizer getting in the way, and there's C. And as you can clearly see, all I've done is I've projected everything perpendicular to the axis or parallel with the line A to A1. Now, rule of thumb here is to find all the other points B, C and D, you take the distance from the axis where the B line crosses over the axis, mark the distance from the axis to point B to find the mirror image of it at the opposite side. Do the same thing with C. So I adjust it out to here. There's C. I need to extend that one a little bit further, and the same thing with D. And there we go. Now, all I need to do is actually extend those lines a little bit, and this one as well, and there we go. Now in regards to labelling, if this is A1, here's B1, then I've got C1 here and I've D1 out here, and now we can draw in the bottom part of our object. So I know A connects to B, I know B connects to C, C connects to D, D gets back to A. Okay, so I know that. Now what I'm going to do is simply, I'm just going to get my marker here to heavy it in. And you can see it's standing out there a little bit more. So I've got the bottom portion. Now what I want to do is I want to get the bit here at the top. Now the easiest way for me to find these 3 points here, 1, 2 and 3, is simply mark them down until they hit the line. They're on the line CD. So if I take my set square and I put it on any of the lines that I projected, I'll just join B to B1. And all I want to do now is take this point here, so slide in set squares and slide it along until it hits that line there. It's that line there, and that line there. And all I've now is I've found those 3 points. So what do I want to do now? I want to find the next 3. So rule of thumb here, I go to the top points and mark them like this. And they'll be out along there. Now, simply a case, go to your axis, you need to find the correct point where it crosses over. Take the distance up to there, then mark it down. As you can see, I found one. I'm going to go into the next one. Just slightly. There's the next one, and finally the third one. As you can see, you need a good sharp compass for this. And there's my points. There, there, and there. Now what should end up happening here is they should nearly end up meeting as straight lines. I'm just going to check. Yeah, axis is okay. and this should end up meeting nearly as a straight line here. Yep, happy with that. Now let's just heavy it in. There's those. This guy. This. And this. And there we have the axial symmetry of that object along this axis line. So let's move over here to the next one, which is based on kind of an arrow inside of a circle. Now in this one here, they did not give us the axis line, but they have told us we have a point in here that is point B, and they've given us the new position where it will be in B1. So how do I find my axis? Because I have the new position of B1 and B is connected to that, if I bisect that line there, I get the axis. So if you put your compass on that line, set your distance to greater than halfway, and we're going to bisect that line. So we can arc both sides, compass on B, and we're going to bisect that guy. Okay, now that I've bisected that, that's my axis, my right axis there. Now, what is the most important point I want to find in this object? Well, the most important point for me, I'm going to call it C, is the center. Because once I have the center, I can then draw in the small circle and the large circle, and then we'll work onto the arrow. So, how do I find the center? Parallel to the line B to B1, because that's going to be perpendicular to my axis line. So, B to B1. I'm going to project that out, and now I'm going to take the distance from the axis to C, which is the center, that distance there. I'm going to mark it out here, and there we go. I've now located the new center, which I'm going to call C1. Okay, now that I have the new center, I can go up here and I can take the radius from up here. So I've got the large radius first. I'm going to put C in my compass on C. Okay, now I'm going to take the smaller radius. Once again, compass on C. Okay, now I've got my two circles. The next thing I actually want to do is I want to find, see this little line here, the vertical line. Okay, now what I actually want to do is I want to find, let's say I'm just going to call it, I'll call this point here, let's say we call that point A. I've got B and C here, so I'm going to call this D. Okay, now what's helpful about the line from A to D is the arrow is actually on that line, okay, that line of the arrow. So if I want to find A, well, what's the rules? I'm going to go parallel to the line there, my projection line, perpendicular technically to the axis. From A, I'm going to mark that out. More than likely this will be A here. I'm going to do the same thing with D, and more than likely that will be D. But just to prove it, if you put your compass here, adjust the distance out as far as A, and let's just check. Yeah, it's matching up with the opposite side. A little bit of inaccuracy. It's very hard to be on the money with these questions. There we go. Mark it out. More than likely you can see that there. It's hitting right there. So that distance there, really handy, is hitting right there. So I'm happy with that. Now I've technically found a new position for D, which I'm going to call D1, and I've got here, which is A1. And more importantly, I know A connects to D through point C. So hopefully, I'll draw that in. We can clearly see I've got my line. Tiny bit of inaccuracy in the middle, but I'm happy with that. Now, I found A, B, C, and D. So let's say we label 2 more points. Let's say I want to find this point here. So if I go with, or I'll actually go with the line first. So E and F. Now that's 2 points there, let's say we have them. Now, more importantly, an easier way for me to even find them is actually just going perpendicular, because the vertical line and the horizontal line are perpendicular. So if you take your 45-degree set square, okay, and I want to go perpendicular to that line, if you put this side of the 45-degree set square on it, see there, if I go like that, and I put it on the line that I already have, and then take your set square and slide it across the opposite way, we can now go perpendicular. And now I can go like this. Okay, so technically, if I follow D out, it should end up hitting here. Call it E1. This should be F1. Now, have I found any points on the arrow? So let's find. Okay, so if I look where A is, look up here, well, that's definitely a point. So I found that point. There's a point here at the opposite side and connected to there. Okay, so if I heavy that in, that's the starting of the arrow. And now what I want to do is I want to find these points. So quite easy. I want to see how far they go down. So take any line, doesn't really matter which one you take. Bit of sliding set squares, and I want to find this point, which is the line connecting A to C. That's going to end up hitting right there. And the same thing with this one. There we go. And there we go. And I can see how far I have to heavy it in. There and there. Okay, now I know the lines are going to end up going out like this. So what you could do here, really easily, if you put your 45-degree set square, okay, we don't actually have to project everything out. If you take your 45-degree set square and you put it on the line A to D, like that, and go like this, and then if you slide it across, well then I know that that line there is perpendicular. So if I just go out like this, perpendicular out, from that point, perpendicular out, and then parallel to the line through B, and there we go. That's one way of doing it. You could also go through the process of projecting out every point on the object and finding it by axial symmetry. So I could. Okay, you could technically get this point here, project it down and take the distance and mark it down, okay? But what I will say is if you recognize the geometry in the project or in the object, you should be able to figure it out a little bit easier than having to bring down everyone, okay? So you can see how I identified some key points there, and then I used, I suppose, the points that were on the lines to figure it out, and then going parallel or perpendicular and recognizing the relationships of the lines. Okay, so that's the second question done there. Now the last question here, we have this little lightning bolt. They've given us a point C, so I'm going to say this is D, E, F. If that's C, I'm going to say this is B and this is A. So A, B, C, D, E, F. And I'm going to say we have a letter G there. So how do I find it? They've already given us the line from C to C1. So I want to get my axis then, so I have to bisect that line. So from C to C1, let's bisect. So now that I have the axis, draw that in. And there is my axis. Now all those points have to project out parallel to the line C to C1, perpendicular to the axis. There's B. Let's find A. Let's project out D. G, E, and F. And you can see there, all I've done is projected them out. Now, I'm going to start with this one here, which is B. Let's take the distance from the axis to B, mark it out. C is done. Next one here is A. I'm just going to work my way down, see what it connects to. Distance out to A, I will need to extend that line there a little bit. Next one is D. Mark it out as far as D. Next one for me is actually G. And once again, I may need to extend my line there for that one. So I will extend my line on a few of them, just so I don't get confused here. Okay, the next one I have is E. Distance from the axis to E. And finally, distance from the axis to F. And I mark it out. Just fits on the page over there. Okay. And this is why I would use indexing. So this one here is B1. This one here is A1. This one here is D1. Okay. This one here is G1. This one here is E1. and this one out here is F1. So I know now, excuse me there, I know that the object goes from A to B, B to C, C to D, D to E. I should put my points on all of them. E to F, F to G. So E to F, F to G, and G back to A. Okay, there's my object. Now, just with the marker, once again, just for demonstration purposes, I'll have it in. A to B, B to C, C to D, D to E, E to F, F to G, and G to A. Okay, so there you have it, folks. There is 3 questions done based on the topic of axial symmetry. Now, I wouldn't expect these questions maybe to come up, maybe something like this one, or this one, but the ones with the circles, they do tend to probably stay away from them when it comes to an exam. But these ones are probably a little bit more of a true reflection of what could come up in an exam. That's a couple of questions done there, guys, on axial symmetry. I hope you found that helpful. Okay.